Good people, look at the horizontal projectile. Now, let us look at horizontal projectile. Horizontal projectile, we are dealing with angle. Now, if we want to cover greatest displacement, the angle of projection, this angle here of projection, it has to be 0 and 45 degrees. Then we'll cover the greatest range. It is called the range or displacement. Ne? Now, if we want to cover the greatest height, then the angle of projection, it has to be 45 to 90 degrees. Then we will cover the greatest height. We'll cover the greatest height there. Okay. Now, that's what we'll be basically dealing with. Now, the formula of calculating the height, would be h equals to u squared sine squared alpha over 2g. Okay, or in your books most probably it is written as 2u over 2g sine squared alpha. This is the formula that we will be using. Then if you are given time, the time taken for an object to reach the greatest height, then this formula it is appropriate. Oh, my things are stacking now. This formula it is appropriate. It is u sine alpha multiplied by time minus 1 over g t squared. Now that formula it is appropriate to calculate what? To calculate height. If you are given what? If you are given time taken for an object to reach that maximum height. Okay, that formula. But you can tell that those formulas are formulas of motion. Formulas that we dealt with under what? Under motion. Even the first one, it is taken from the formulas that we know of what? Of motion. Okay. Don't then be surprised and say, where are those formulas coming from? These are the formulas that you know how to write. These formulas, they deal with what? With height. Okay. They deal with height. Now let's look at the formulas of calculating the range. The range would be from here to there, the greatest displacement. The height from here to there, up there. Okay. Now the formulas of calculating the range would be L, denoted as range. It is u squared over g multiplied by sine 2 alpha. These are your double angles. This it is your identities. This it is your double angle. Or if you are given time in calculating the displacement or range, it will be S equals to U multiplied by cos alpha multiplied by time. Now these ones are formulas of calculating what? The range and displacement. Are formulas of calculating the range and displacement. If they say calculate the range, you will use this formula. If they say calculate the displacement and you are given time, you will use that formula. And here's another thing. You can be given time for height and they want you to calculate the displacement. You can always use this time here to calculate that displacement there. Okay, now these are the formulas that we'll be dealing with to calculate whatever that they want us to calculate. Now let's look at some application of these formulas there. All right, let's look at this one. A shell is fired with the muzzle velocity, okay, we are given the initial velocity, it is 700 meters per second. We are given the angle of projection, it is 15 degrees. To calculate the full horizontal displacement or distance. Now, we are given time on this one. Can you see that? The horizontal displacement or distance of the shell. Now, it then means in calculating the horizontal displacement, we'll be using S equals to U cos alpha multiplied by time. Do we have initial velocity? Yes, we do have. It is 700 multiplied by cos 15 multiplied by 10 seconds. Then our displacement would be, um, I'm looking for my calculator. Where's my calculator now? Oh my goodness. Let's pause the video a bit so as to look for the calculator. Let's pause. Right, I found my calculator. Now it will be 700 multiplied by cos 15 multiplied by cos 15. So 700 multiplied by 10 multiplied by cos 15. Now I get my answer. Please somebody verify for me if that is the answer. It's 6,761,481 meters. Okay, that's the answer that I'm getting. Now somebody verify for me. Ne? Right, that is the answer that I'm getting. We managed to calculate the first question. They want us to calculate the height of the shell after. Now, this is the formula that we'll be using to calculate. It is ut, it is u sine alpha t minus 1 over 2 gt squared. Okay, it is 700 multiplied by sine 15 multiplied by 10 minus 1 over 2 multiplied by 9,81 multiplied by 10 squared. Now, let's see what do we get here. It is 700 multiplied by sine 15 multiplied by 10 minus 0.5 multiplied by 9,81 multiplied by 10 squared. Right. Okay, I get my height as 1,321,233 meters. Okay. Now let's switch the pens. The question number C, they want us to calculate the range of the shell. Now, in calculating the range, this is the formula that we'll be using to calculate the range. Let's wipe here so that we can write everything in one page here. Okay. Now, they want us to calculate the range. In calculating the range, it is L u squared over g sine 2 alpha. Then it will be 700 squared divided by 9,8 sine 15 multiplied by 2. Double angles, don't forget that. Then you are having 700 squared over 9,81. Let's use 9,81 multiplied by sine 30. 15 multiplied by 2, it's sine 30. Sine 30, we know that it is 0.5. Now we know that it is 0.5. Multiply by, let's get this, it's 700 squared divide by 9,81 multiply by 0.5. Then I get my range as 24,974,516 meters. Now the last one, they want us to calculate the maximum height. In calculating the maximum height, let's wipe here. In calculating the maximum height, it will be h equals to u squared over 2g sine squared alpha. Then we are having 700 squared divided by 2 times 9,81 multiplied by sine 15, open bracket, close bracket, squared. If you don't want to compute it this way, you can repeat sine twice because it's your identity. It will be sine 15, sine 15, close bracket. You can repeat it twice. It doesn't matter. It's up to you. How do you want to work with it? Okay, divide by 2 times 9,81 multiply by sine 15, sine 15. Now I get my answer on the height as 1672,975 meters. This is how you deal with horizontal projection. Let's look at another question. We dealt with that one. Okay, those were the two questions I've prepared for us to. This one we've already dealt with it. It's your vertical projection. This one, it is your horizontal projection. Right. This is how you deal with your projection. Thank you, good people.